Hello everybody, welcome back to another NumPy video. In this video, we're going to introduce Matplotlib. This is the first video in our 5-part series on Matplotlib. So what is Matplotlib? It's a plotting library. It's arguably the most famous and the most important Python plotting library. If you stick around for Math 10 next quarter, you'll probably see us use different plotting libraries such as Altair and Seaborn. But I would be doing you a great disservice to not at least show you Matplotlib in Math 9 this quarter. So let's get started. As usual, I'm going to import NumPy as NP. And now we're going to import Matplotlib, but we're not going to import all of it. We're just going to import what we need for today. So I'm going to say import, then matplotlib.pyplot as plt. So what this is saying is from Matplotlib, take pyplot, and we're going to be calling it as plt. Like usual, this is a standard convention, so we're going to always use plt. I can run the cell, and we can see it's imported both of these with no problem. Another way we could do this is we could say import, or instead, how about like this? I can say from Matplotlib import pyplot as plt. This will work just fine, but we don't need both of these statements. So I'll comment this one out just as another way for you to see. Great. So what I'm going to show you in this video is something called the object-oriented syntax. Matplotlib has two main syntaxes that we use. For Math 9, Sorry, my cat is meowing. You good? It's okay, I can edit this out. So as I was saying, two main syntaxes. First is object-oriented syntax. That's what I'm going to show you in the video today and what I want you to use for Math 9. The other syntax is very close to MATLAB, but again, not something I particularly want us using for this class. So let's get started. First thing I'm going to show you is I'm going to say plt.subplots with two parentheses, and I'm going to call this z. And we can see here this plots this kind of blank grid. So that's fine, but what is this object z? So let's start by just calling type on z. And we can see it's a tuple. Maybe you see it's a tuple. What would be the first thing that you ask? Well, how long is the tuple? So let's check length of z. We can see it's a length 2 tuple. Let's take a look at each of these entries. So I can do z of 0. And this gives me that kind of blank square that we were looking at earlier. What's the type of this? So I'm going to do type z of 0. And we're seeing here that it's a Matplotlib figure. So remember I mentioned object-oriented syntax. So this figure object, you can imagine it as the canvas on which we're going to kind of do our painting. So that doesn't make sense quite yet, don't worry. Just imagine it as this is kind of the outside container that's going to hold everything that we're plotting. So we looked at the first coordinate, or the first entry in the tuple. What's the second entry? So this is something called an axes subplot. Let's check the type. And we can see here, this is an axes subplot object. What is an axes subplot object? Well, the axes objects, what these are going to do is store the data that we're actually going to be displaying. So again, figure you can imagine like the canvas, and axes is going to hold the data. So what have I done so far? Not much. I've just shown you two objects from Matplotlib. What are we going to do? Well, let me show you how we're going to set up figures in general and plotting. So I'm going to use something called tuple unpacking. So remember, z is a tuple with two entries. So I'm going to say fig, ax for figure and axes. And again, tuple unpacking. So if I set this equal to plt.subplots, what happens is figure gets assigned to the 0 entry. So this is going to be the figure. Ax is going to be assigned to z of 1, or what we called z of 1 when we started the video. So this will be the axes object. So again, if I run this, exactly the same thing that we've been seeing before, but for instance, notice now if I call type of fig, I get that it's a figure. If I do type of ax, it's this axes object. So remember, The original question or kind of goal of the video that I have stated here is I want us to plot one cycle of cosine. Why cosine? Not super important. Again, the point of this video is just so that you can get a feel of how Matplotlib works and the basic syntax. So what I'm going to do, I'm going to start by copy pasting this fig comma ax line. Then what I'm going to do is I'm going to say ax dot plot. And this is extremely similar to MATLAB, where the first coordinate is going to tell me the vector of x values. The second coordinate is going to tell me the vector of y values. So think of MATLAB, very similar. So let's say I have range of 6, comma, now I want np dot cosine of range of 6, and let's run this and take a look. So we can see here, well, certainly that's the rough shape of cosine, but there's a lot of things not too good about this graph, right? Or even the code that we used to write it. So first thing that goes wrong is this code is not what we call dry. And dry stands for don't repeat yourself. It's one of our principles that we want to learn in this class. So notice here I have range of 6 repeated twice. And instead of having it there, so imagine now I wanted to change this value. Well, now I have to change it in 2 places. So to make it easier for ourselves, what we're going to do instead is I'm going to have a variable x, and this is going to store the x values. So now I can just replace it as x, and then cosine of x. So again, if I want to change the x values, very easy, I change it in one place and then it gets changed everywhere else. So plotting wise didn't make a difference, but it did make our code easier to read, and it adheres to the dry principle, the don't repeat yourself principle. So still a couple of things not so nice with this picture, right? Another thing is, well, this square bracket with these words, not so nice to look at. How we can get rid of that is we can just put a semicolon in this line here. So I run it, and that removes that square bracket at the top. So looking a little bit better, but remember I said I also wanted to plot a full cycle of cosine, right? Notice that range 6, it goes up to 6 but doesn't include it. Cosine has a period of 2 pi, so we want to go from 0 to something a little bit bigger than 6. So instead of having this be range 6, let's change it to range 7, and that's going to be pretty close. So notice how nice, I change it in one place, and now we can see we get a little bit more than one cycle of cosine. Very good. Or I guess since it's range 7 and these are integer values, so I misspoke. This really goes up to 6 inclusive. 2 pi is a little bit bigger than 6, so this doesn't quite hit 1, but it looks pretty close. Good. Maybe last thing that we can critique about this is it's very jagged, right? So remember how this works is it plots, so first coordinates that get passed are 0, 1, and that's fine. And then it's going to connect it to the next one that gets passed. So all of that is okay, but remember, since it's connecting lines, same as MATLAB, if we decrease the size of the line between points, it's going to look a lot smoother. So one thing that we can do is, well, we can just increase the number of points. So we could try doing something like, let's say, start at 0, go to 7, increase by 0.1. This is going to cause an error. Does anybody see what it is? This is, remember, the range method. Range function, what this needs is integer arguments, right? So instead of calling range, we could do np.arange, and this should work just fine. So already this is looking better. And notice now we've gotten more of the graph because now we're able to go past 6. So here we get more than one full cycle. So this is looking very smooth already. Maybe one other way that we could do this is, instead of using arange, another function that should make you think MATLAB is we could do np.linspace, and I can say start at 0, go to 7, include 100 points, and see here we get, again, very smooth graph. So I think this is a good place to stop the video. Again, this is just the basic syntax of how do we plot something in Matplotlib. In the upcoming videos, I'm going to show you the other types of syntax. We'll talk about how to make these graphs look a little bit more modern, and I'll show you plotting multiple figures. Thank you for watching, and I'll see you in the next video.